I'm Zhang Hailiang. I'm working in Huawei company. My topic is the status update about COLO FT. In this presentation, we will talk about the coarse-grained lockstepping, virtual machine for non-stop service technology. We have 4 parts to introduce. In the first part, we will introduce you the concept of coarse-grained lockstepping, and then we will talk the details about the COLO design and some technology details. Then in the third part, we will give you some information about the current status of COLO in QEMU platform. And since COLO is still a prototype, so there are lots of future work needs to be done to improve it. Let's start the concept of virtual machine replication. So what is VM replication? In short, it is a software solution for business continuity and disaster recovery through replication-agnostic hardware fault tolerance by replicating the state of primary VM to the secondary VM on different physical nodes. Here we call the primary VM as the PVM and the secondary VM as the SVM for short. Just as shown in this picture, there are 2 physical nodes. The PVM is running in the primary node, and the SVM running on the secondary node. The state of the PVM is synchronized to SVM in a specific frequency, and so the SVM is a valid replica of the PVM. If there are hardware fail stop failover detected by the equipment, the SVM will take over the service. So generally speaking, there are 2 kinds of VM replication approaches. The first one is the lockstepping. It is an instruction-level lockstepping method. In this approach, PVM and SVM execute in parallel for deterministic instruction. In contrast, lockstepping is applied for non-deterministic instruction. So for this replication approach, it's only suitable for single processor VM, and their performance will degrade dramatically. Another VM replication approach is the continuous checkpoint. It's in this approach, the VM states are replicated at each epoch. It's well known as the period VM replication, just as the reverse on Zen platform and micro checkpointing on QEMU platform. All these 2 VM replication approaches have some defects. As you can see from their principle, they all suffered from excessive overhead. I mean the VM checkpoint. So their performance is not good. That's why we introduce a new and more efficient VM replication approach. In this VM replication approach, we consider the VM and the clients as a system as a system of networked request response system. So the clients only care about the response. If the PVM and SVM in the VM replication can reply with the identical response, from the client's point of view, they consider both of them are in the same state. It doesn't matter it's their internal state. Based on this output similarity principle, we propose the new VM replication approach named as the coarse-grained lockstepping virtual machine for non-stop service. We call it KOLO for short. In this approach, it runs PVM and SVM in parallel, and it compares the output response package. So if the compare result is identical, then it will not need to do the checkpoint. If the compare result is not identical, then it indicates that we need to do the checkpoint to synchronize the states of SVM, PVM to SVM. So from the principle of KOLO, we can see that it is actually an improved solution of the continuous checkpoint. So it's more efficient compared with the continuous VM checkpoint because it highly reduces the checkpoint frequency. As you can see, the principle of KOLO is simple, but it does work. Okay, let's talk about the design and the technology details of KOLO. This diagram is the architecture of KOLO. It consists of a pair of networked physical nodes. The primary node running the PVM and the secondary node running the SVM to maintain a valid replica of the SVM. The heartbeat components running on both physical nodes. They can periodically check the platform availability. So if there are hardware stop failure, they can detect it, and the secondary node will trigger a failover process so that the SVM will take over the service. For the checkpoint, for the VM's checkpoint, we achieve it by reusing the live migration on QEMU platform. So for this part is not complex. For the KOLO desk manager, it's used to realize the block replication. We know that for KOLO, the key characteristic for KOLO is it uses the compare results to determine whether or not to do the checkpoint. So we need a module to do the comparing task. That is the KOLO prox. Okay, we will talk about the details of some components in this picture. So first, let's talk about how block replication works. There are two diagrams. The first diagram is about the non-shared desk workflow, and the second one is the shared desk workflow for VM replication. And we can see that the replication process of SVM's storage are quite similar. Let's take the non-shared desk workflow, for example, to illustrate the block replication process. Here we play a trick to support the desk content checkpoint. We will not allow the SVM write their own desk directly. Instead, we use a desk buffer to cache the. Sorry. here we use a desk buffer to cache the SVM's writing so that it can't write directly into its own desk. To achieve the checkpoint, we need to copy and forward the PVM's writing dates to the secondary desk. But before this dates being written into the secondary desk, we need to copy read its original content from the secondary desk to the desk buffer, so that to achieve the checkpoint is very simple. We just imported the desk buffer to achieve the checkpoint, so that the content of desk in the desk for SVM and desk for the PVM are identical after a checkpoint. When do failover process is only need to flush the data that's stored in the desk buffer into its own desk. I mean here it is the secondary desk to achieve the failover process. Okay, let's see how the VM state checkpointing. For this part, actually, it is based on the live migration on QEMU. It's not complex. Let's take a look at the workflow. The primary node will check if it needs the checkpoint. If the answer is yes, the primary node will send the command to the secondary node to ask for checkpoint. And then the secondary node will pause VM. And it also reply with a checkpoint reply message to the primary node. After that, both the PVM and SVM are paused. And then the primary node will migrate PVM state to the secondary node. But here it will not flush the dates directly into the SVM, because during the process there may be some error happened. So here we first store the PVM state into the memory buffer first before flush these dates into SVM. After secondary node receives all the complete dates, it then flushes the dates from the memory flash to the SVM. After that, both the PVM and SVM resume to run state again. So the process is simple. But you maybe note that we need to pause VM during the checkpoint. So if the time is too long, we can see that the performance of the VM will be degraded dramatically. So we need to reduce the pause time for the checkpoint. Actually, we can optimize it from several aspects. First, we can reduce the transmitted dirty pages that when do checkpoint. Second, we can reduce the amount of updating dirty page from the desk buffer, from the memory buffer. And the third method is to reduce the time of flashing dates. Okay, here is the COLO proxy design. We know that the main characteristic for COLO is it uses a net package comparing result to determine the whether or not to do the checkpoint. So the COLO process, the design of COLO process is quite important. In this process, we need to unpackage the network package, and also need to manage the connection. So a good idea is to reuse the TCP/IP stick and net filter components that in kernel, because it can help us to analyze the package. Yes, we do realize this scheme firstly, just based on the TCP stick and the net filter components, and it does achieve comparable performance, but unfortunately, we need to modify the kernel and the IP tables components, and it seems less acceptable for the kernel community. So we have no choice, and we realize another scheme and release it totally in the user space. To be exact, totally in QEMU. And the lucky thing is that the QEMU also has its own TCP and IP stick named as SLIIP. So we realize the user space scheme based on it. And compared with the kernel COLO prox scheme is more flexible. So this is the user space scheme. As you can see, we realize several filter plugins to achieve different functions. The filter mirror used to copy and forward client's package to the SVM, because in this architecture, the package that from the clients and the external network only be sent to the primary node. So we need components to copy and forward the package to the secondary node. So here the filter mirror plugins to achieve this purpose. The filter redirector plugin here is to redirect the package, and we also have independent COLO compare components to achieve the comparing task. So yeah, that's all. And here is a test that based on kernel prox scheme. From this test, we can see that it does achieve a good performance. Here, the test results has been normalized to the native system to see the difference and its performance. We can see that COLO can achieve 80%, almost 80% of the native system. And it can achieve 96% of the peak performance. So the performance, I think, is very good compared with these two VM replication that we talked before. So for the current status of COLO in QEM is we divide COLO into 3 parts by the function and posted their patches separately as 3 single series to community. The COLO framework, the COLO block replication, and the COLO prox. And for the COLO framework, it is only includes the VM state checkpoint process and the failover process. We have posted the 18th version to the community, and it is under review now. For the block replication, we have posted the non-shared storage replication scheme, and it has been accepted and has been merged to Stefan's branch. I think it will be go to the upstream soon. For the COLO procs, we achieve several plugins and set them separately, and part of them have been merged into upstream, like the net filter base, net filter buffer, and the mirror. For the user space package compare series is still working in process, and the 11th version has been posted. So as you can see, COLO is still a prototype, and there are lots of future work needs to be done to improve it, to make it be commercial usage. And first, I think we need to revise the patches according to the review feedbacks and get patches accepted into upstream. Then we need to develop the continuous VM replication. And third, we need to support the shared disk. And what's more important is we need to optimize the performance, because after we switch to the user space COLO procs scheme, I think the performance will be degraded. So we need to do that. So that's all. Any question? Okay.
So I have a couple of questions regarding the checkpoint. So when you have to do a checkpoint, do you need to copy all the memory from the PVM to the SVM?
No, we only need to the increment dirty pages. Yeah, because we have a copy. We keep a copy of the PVM in the secondary node.
Okay.
Yeah.
All right.
Yeah.
I see. So another question is, how often do you have to do a checkpoint?
Actually,
for various benchmarks.
Yeah. Actually, in our test, we found that in most cases we don't need to do the checkpoint. So actually, we have some we have optimized it as the period checkpoint about 10 seconds. If the compare result is always identical,
right,
we still need to do the checkpoint about 10 seconds a time, and you can configure it.
Seconds.
Yeah, you can configure it.
Okay.
Yeah.
How much random
Yeah. That's true. Yeah.
Okay. And when you do a checkpoint, what's the blackout time? Like how long does the VM pause when you have to do a checkpoint?
You mean the pause time for?
Yeah, the average pause time. Do you have any?
It all depends, I think. Actually, we do have several methods to reduce it, and I think we can reduce it inside 1 second. I think we can achieve this target.
Okay. All right.
Yeah.
Thanks.
So thank you.